dear students of third prep. Today we are going to have two new lessons. The first lesson is how to solve two equations in two variables. One of them of the first degree and the other is of the second degree. And the other lesson is how to find the set of zeros of a polynomial function. Let us start by the first lesson, which is solving two equations in two variables. One of them is of the first degree and the other of the second degree. First of all, when you have the two equations, x minus y equals 1, and the other one is x to the power of 2 plus y to the power of 2 equals 25. Now, I want you to notice that one of them is of the first degree, which is x minus y equals 1, and the other is of the second degree, which is x to the power of 2 plus y to the power of 2 equals 25. And here, I want you to find the solution set of these two equations, x minus y equals 1 and x squared plus y squared equals 25. At the very beginning, you are going to look carefully to the first degree equation, which is x minus y equals 1. Try to find either x or y. I always prefer that you know that you are going to choose the one which its coefficient is 1. So what about the coefficient of x? It's 1. What about the coefficient of y? It is negative 1. So try to find the value of x as its coefficient is 1. Now, can you find x now? Of course, yes. As x minus y equals 1, then x equals 1 plus y. Now we have found that x equals 1 plus y. By taking the value of x, which is 1 plus y, and substituting with it in the second degree equation as follows. So, instead of x, write 1 plus y all to the power of 2 plus y to the power of 2 equals 25. Can you obtain a value for 1 plus y all to the power of 2? Of course, yes. Its expanded form will be 1 plus 2y plus y to the power of 2 plus y to the power of 2 equals 25. By putting the whole equation on one side, you are going to find that 2y to the power of 2 plus 2y minus 24 equals 0. By dividing the whole equation by 2 as it can be divisible by 2, you are going to obtain another equation which is y to the power of 2 plus y minus 12 equals 0. When you look carefully at this equation, you are going to notice that you can factorize such an equation. So what about y power 2? It is y and y. What about 12? It may be 1 by 12, it may be 2 by 6, and it may be 3 by 4. What are you going to obtain? You are going to obtain 3 by 4. Why? Because the difference between them gives 1, which is the middle term. The last term is with a negative sign, so one of the brackets is positive and the other negative. According to the sign of the middle term, the greater number will take the positive sign. So you are going to obtain two brackets as y plus 4. The other bracket is y minus 3 equals 0. Now, two brackets multiplied by each other equals 0. It means that either the first one, y plus 4 equals 0, or the second one, y minus 3 equals 0. In this case, we can find that the value of y equals negative 4. Or the value of y will be 3. By substituting for the value of y as negative 4, you are going to obtain that x equals 1 plus y. So it is x equal 1 plus negative 4 to obtain a result as negative 3. And when y equals 3, so x equals 1 plus 3 gives 4. In this case, you have two solutions. As the value of x is negative 3, its value of y will be negative 4. So the first order pair will be negative 3 and negative 4. What about the other order pair? When the value of x equals 4, the value of y will be 3. So in this case, we can say that the other solution is 4 and 3. So you have two solutions. What are they? Negative 3 and negative 4, or 4 and 3. Now you have found that the solution set for the two equations, one of first degree and the other of second degree, will be negative 3, negative 4, or 4 and 3. Another example. Find the solution set of the equations. Y plus 2x plus 1 equals 0. And the other equation is 4x to the power of 2 plus y to the power of 2 minus 3xy equals 1. You are going to look carefully for such two equations. Which of them is of the first degree? The first one, which is y plus 2x plus 1 equals 0. Now, look at the coefficients of x and y. Which of them is of coefficient 1? It is y. So try to find the value of y. So as y plus 2x plus 1 equals 0, then y equals negative 1 minus 2x. By substituting for the value of y equals negative 1 minus 2x in the second degree equation, you are going to obtain 4x to the power of 2 plus, instead of y, right, negative 1 minus 2x all to the power of 2 minus 3x multiplied by y, which is negative 1 minus 2x, equals 1. By writing it in the expanded form, you are going to obtain 4x to the power of 2 plus 1 plus 4x plus 4x to the power of 2 plus 3x plus 6x to the power of 2 minus 1 equals 0. When you look carefully to such an equation, you are going to notice that there are like terms. So try to collect the like terms together. We are going to add 4x to the power of 2 plus 4x to the power of 2 plus 6x to the power of 2 to obtain a result as 14x to the power of 2. Then what about 4x plus 3x? It is 7x. So 14x power 2 plus 7x. What about 1 minus 1? It is 0. So by collecting the terms, the like terms, you are going to obtain a result as 14x to the power of 2 plus 7x equals 0. Look carefully to such an equation. Can you factorize it? Of course, yes. But how? By taking 7x as a common factor. Then, to find the values inside the brackets, you are going to divide 14x to the power of 2 divided by 7x gives 2x, and 7x divided 7x gives 1. So it is 7x brackets 2x plus 1 equals 0. Two terms multiplied by each other equals 0. So either the first term, which is 7x equals 0, or the other term, which is 2x plus 1 equals 0. To find the value of x, you are going to divide both sides by 7 to obtain a result for x as 0. The other side as 2x plus 1 equals 0, then 2x equals negative 1, and finally x equals negative half. And in this case, we can say that the values of x are 0 and negative half. Now you have found the values of x. Then try to find the values of y. As y equals negative 1 minus 2x, so substituting for the value of x equals 0. It is y equal negative 1 minus 2 times 0 to obtain a result as negative 1. So when x equals 0, y equals negative 1. What about x equals negative half? By substituting, y equals negative 1 minus 2 times negative half gives a result as 0. So when x equals negative half, y equals 0. What about the solution set? Solution set is when x equals 0, y equals negative 1, and when x equals negative half, y equals 0. Let us have another example. A story problem which says that a rectangle of perimeter 20 centimeters and area 24 centimeters squared. Find its two dimensions. Here the given is a rectangle, its perimeter is 20 and its area is 24. And I want you to find its two dimensions. What are the two dimensions of the rectangle? They are the length and the width. Its length and its width. So, by using your rules you have studied before, all of you know that. Let the two dimensions first be x and y. Then, to find the perimeter, it's 2 multiplied by x plus y, which gives 20. So, we can say that also its area is x multiplied by y, length multiplied by width, which gives 24. Here, x plus y, by dividing both sides of the perimeter by 2, so x plus y equals 10. And x will be 10 minus y. This is the first degree equation. We have obtained the value of x as 10 minus y. Or somebody else says that I want to find the value of y. It is 10 minus x. It's correct. Both are correct and both gives the same answer. It doesn't matter. You can choose what you like as their coefficients. Both of them is of coefficient 1. Then, as x equals 10 minus y, we are going to substitute by the value of x in the rule of the area. So, by substituting, it is 10 minus y multiplied by y gives 24. By writing its expanded form and putting the whole equation on one side equals 0. So, it is 10y minus y to the power of 2 equals 24. And then in the general form it will be y to the power of 2 minus 10y plus 24 equals 0. Look carefully, you are going to make the factorization. The two brackets will be y and y. What about 24? It is 1 by 24, or 2 by 12, or 3 by 8, or 4 by 6. Which group are you going to choose? You are going to choose 4 by 6. Why? Because their sum gives 10, which is the middle term. And also the last term is with a positive sign. So the two signs will be like each other, either both positive or both are negative. You are going to choose that both of them will be negative as the middle term is of a negative sign. So the two brackets will be y minus 4, the other bracket is y minus 6 equals 0. Two terms multiplied by each other equals 0, so either the first term y minus 4 equals 0 or y minus 6 equals 0. To obtain a result as y equals 4 or y equals 6. Now you have obtained the values of y as 4 and 6. Can you find the value of x? Of course, yes. As x equals 10 minus y, so x is 10 minus 4 gives 6, or x equals 10 minus 6 to give 4. So in this case, we can say that the two dimensions x and y are 4 and 6. And we can say the two dimensions of this rectangle are 4 centimeters and 6 centimeters. Let us have another example. A right angle triangle of hypotenuse length 13 centimeters and its perimeter is 30 centimeters. Find the length of the other two sides. At the very beginning, you have a right angle triangle. The length of its hypotenuse is given as 13 centimeters. Then we don't know the two sides adjacent to the right angle. So we can say that let the two sides be x and y. What about its perimeter? The perimeter of a triangle is the sum of length of its sides. So we can say that perimeter equals the sum of its sides, which are 13 plus x plus y equal 30. Then can you find the value of x plus y? Of course, yes. X plus y equals 30 minus 13 gives 17. And what about the rule of Pythagoras theorem? Do you remember? The two adjacent sides to the right angle to the power of 2, when you find their sum equals the length of the hypotenuse to the power of 2. So it is x to the power of 2 plus y to the power of 2 equals 13 to the power of 2. From the perimeter, you can find that x plus y equals 30 minus 13 equals 17. And here you can find either the value of x or the value of y. Why? Because both of them is of coefficient 1. If I find the value of x equals 17 minus y, and by substituting with this value of x in the second degree equation, you are going to obtain a result as 17 minus y all to the power of 2 plus y to the power of 2 equals 13 to the power of 2, which gives 169. By writing the problem in its expanded form, so it is 289 minus 34y plus y to the power of 2 plus y to the power of 2 equals 169. And by collecting like terms, you are going to obtain a result as 2y to the power of 2 minus 34y plus 289 minus 169 equals 0. By collecting also like terms, it is 2y to the power of 2 minus 34y plus 120 equals 0. When you look carefully to such an equation, you are going to notice that it can be divisible by 2, as its coefficients are all even numbers which can be divided by 2. So by dividing by 2, it will be y to the power of 2 minus 17y plus 60 equals 0. Yes, of course, you are going to factorize y and y. What about 60? It is 1 by 60, 2 by 30, 3 by 20, 4 by 15, 5 by 12. Which group are you going to choose? It is 5 by 12. Why? As their sum will be 17. And the last term is positive, so both terms are like each other. Either both are positive or both are negative. You are going to choose the negative sign for both of them, as the middle term is of a negative sign. So the factorization will be y minus 12 multiplied by y minus 5 equals 0. Two terms multiplied by each other equals 0. It means that either y minus 12 equals 0 or y minus 5 equals 0. And in this case, we can obtain the value of y as 12 or the value of y as 5. Then, now you have found the values of y. Can you find the value of x? Of course, yes. As x equals 17 minus y, so when y equals 12, so x is 17 minus 12 gives 5. And when y equals 5, so the value of x is 17 minus 5 equals 12. And in this case, we can say that the two sides of the triangle are 5 and 12 centimeters. Now, what about the set of zeros of the polynomial function? First of all, if you have a function called f from r to r, where f of x equals x to the power of 2 plus 7x plus 10. It is a polynomial function of the second degree in x. Now, if you try to find f of negative 5 and f of negative 2, what are you going to notice? Let us start first by finding f of negative 5 by substituting for the value of x as negative 5. So it is negative 5 all to the power of 2 plus 7 times negative 5 plus 10. By finding the value using your calculators, you are going to notice that the result will be equal 0. So when x equals negative 5, f of x will be 0, which is y. Then try to find the value of f of negative 2. By substituting, it is negative 2 all to the power of 2 plus 7 times negative 2 plus 10. It will also give a result as 0. Oh, what do you notice? You are going to notice that f of negative 5 equals f of negative 2 equals 0. And in this case, we can say that negative 5 and negative 2 are called set of zeros of this function. It means that when you substitute for x equals negative 5 and x equals negative 2, it makes the function finally equals 0. And it is called what? Set of zeros of the function. Then we can say that z of f equals negative 5 and negative 2. What's the meaning of z of f? It means the set of zeros of the function f is negative 5 and negative 2. And what is the meaning by set of zeros? It means the values of x which makes the function equals 0. Now let us have some examples. Find z of f of the polynomial function f of x equals x squared minus 3x minus 10. It means that I want you to find the values of x which makes this function f of x equals 0. So we are going to take x to the power of 2 minus 3x minus 10 and make it equal 0. Of course, yes, when you look at it, you are going to notice that you are going to factorize 2 brackets, x and x. What about 10? It is 1 by 10 or 2 by 5. What group are you going to choose? You must choose. You are going to tell me that it is 5 and 2. Why? Because the difference between 5 and 2 gives 3, which is the middle term. But here, the last term is with a negative sign. So bracket will be with a positive sign and the other will be with a negative sign. And the greater number will take the sign of the middle term. So the greater number is 5. It will take the sign of the middle, which is negative. And the other one will be with a positive sign. So the two brackets will be x minus 5 multiplied by x plus 2 equals 0. Now you have two terms multiplied by each other equals 0. It means either the first one equals 0 or the second one equals 0. So we can say that x minus 5 equals 0 or x plus 2 equals 0. And in this case, the value of x will be 5. The other value of x will be negative 2. Here we can say that the set of zeros of the function f equals 5 and negative 2. Another example. Find set of zeros of the polynomial function f of x equals x squared minus 9. To find set of zeros of the function, we are going to equalize this function by 0. So we can say that x to the power of 2 minus 9 equals 0. By making factorization, x and x. What about 3? It will be 1 by 9 or 3 by 3. In this case, you are going to choose 3 by 3. Why? Because you are factorizing difference between two squares. So the two brackets will be x minus 3 times x plus 3 equals 0. When two brackets are multiplied by each other gives 0, it must be one of its terms must be equal 0. So either x minus 3 equals 0 or x plus 3 equals 0. To obtain a result for the value of x as 3 or value of x as negative 3. And in this case, we can say that the set of zeros of the function f equals 3 and negative 3. Another example. Find z of f of the polynomial function f of x equals x to the power of 3 plus 64. To find the set of zeros, you are going to equalize the function by 0. So x to the power of 3 plus 64 equals 0. Here you can factorize, but there is a much easier way by writing x to the power of 3 equals negative 64 and finding the cubic root for each side. So the value of x will be negative 4. And in this case, we can say that the set of zeros of this function will be negative 4. Another example. Find set of zeros of the polynomial function f of x equals x squared plus x plus 1. To find the set of zeros, you are going to equalize the function by 0. So x squared plus x plus 1 equals 0. You are not going to factorize it. You cannot factorize it. So you are going to use the formula, which gives negative b, positive or negative, square root b square minus 4ac over 2a. What about a, b, and c? A equals 1, b equals 1, and c equals 1. So by substituting, it is negative 1, positive or negative, square root 1 to the power of 2 minus 4 times 1 times 1 over 2 times 1. To obtain a result as negative 1, positive or negative, square root 1 minus 4 over 2. To obtain a result as negative 1, positive negative, square root negative 3 over 2. Oh, do you notice? Yes, we cannot find a square root for a negative number. In this case, it means that the solution set will be phi. It means what? It means that the set of zeros of this function will be phi. No values of x can be substituted in this function to give a result as 0. So the set of zeros of f will be phi. Another example. Find z of f of the polynomial function f of x equals x squared plus 4. Try to equalize this function by 0. So x squared plus 4 equals 0. This cannot be factorized as it is sum, not difference between two squares. So x squared will be equal negative 4. Try to find the square root of the two sides. You are going to notice that x equals square root negative 4. Can you find a square root for a negative number? Of course not. So it means that the set of zeros of the function will be phi, as x equals root negative 4 will be refused. Let us have another example. If z of f equals 5 and f of x equals x to the power 3 minus 3x to the power of 2 plus a. Find the value of a. As set of zeros of the function equals 5, it means when substituting, the value will be 5. Then f of x equals 5 to the power of 3 minus 3 times 5 to the power of 2 plus a. As it is set of zeros, so the answer will be equal 0. By substituting, 5 to the power of 3 equals 125 minus 3 times 5 to the power of 2 is 75 plus a equals 0. By collecting like terms, so it is 50 plus a equals 0. And in this case, we can say that the value of a equals negative 50. By the end of this example, we have reached the end of our lesson today. I wish that all of you understood it and try to solve more and more problems about this lesson so as to continue the next lessons, inshallah. Thank you for good listening and goodbye.